Well, hello everyone. Guess we'll get started. It's right around 2:45. Hopefully you can hear me okay. My name is Scott Sigmund. I'm a solutions architect with Red Hat, actually based in Cleveland, Ohio. And we're going to talk this afternoon around a really cool and exciting technology, especially if you've been a Java developer for many years. I think you'll be really interested in the topic around Quarkus. Now, caveat right up front, for whatever reason, I'm unable to share anything but the presentation. So I can't share my VS Code, I can't share my terminal. So while we'll be able to talk through a lot of the topics that I plan to show you through a demonstration, unfortunately, I'm not going to be able to show you demonstration. I'm not certain as to what's leading to my inability to share anything but the presentation. If I try to share my whole screen, it's just black. So one of those technology hiccups that I'm sorry to report here at the onset. But regardless, we'll walk through the presentation. We'll talk a little bit about Corkus, and I guess what I'll do is maybe I'll record some of the demonstrations I was going to show you, and if you want to send me an email at the email that you see on the screen there, I'd be happy to do that. Send those videos along to you. So let's dig in. Let's talk a little bit about Quarkus and why you should be excited about the technology. Let me start off by first saying that if you're not aware, Red Hat has been a supporter of the Java community for some time now. And because of that, because of our kind of dedication to OpenJDK, we've recently began to run or serve as a steward, I guess we should say, as for the OpenJDK 8 and OpenJDK 11 projects, and I anticipate, as OpenJDK continues down the path, that we'll continue to be the stewards of those particular projects. So that's, I think, for a lot of folks, that's good news, right? We've got a long, obviously, storied history in open source, and we're going to kind of continue to innovate and enable that innovation. Specifically in the Java community, OpenJDK. We're going to continue, as you might imagine, to ensure that all the versions of Java perform as you expect them to perform, and we've got a regular update cadence that we follow, a quarterly cadence for all updates of OpenJDK, and that'll continue going forward. We're speaking of innovation, we're also the upstream lead for Shenandoah. It's a high-performance garbage collector that's now part of OpenJDK 12. It's been backported to 11 also, and 8 for that matter. But we're leading those efforts too. And just a little bit more about us and OpenJDK. We're members of the vulnerability group and the governing board, and we've done a lot to make certain that Java runs well in Kubernetes environment, which a lot of organizations are using or on a path to using. And we've been involved in a lot of different other projects in the Java community, some that you're probably really well familiar with. And of course, we established the Corkus project, which is where we're going to focus our discussion here this afternoon. So why Corkus? Going back to the excitement that I think this is going to bring to Java developers, the intention here was to write or create a framework or stack that allows you to write Java applications that are tailored and optimized for cloud-native environments. So, those hybrid cloud platforms like Kubernetes that we just talked about, be able to support those 12-factor applications that a lot of you are using today in your Java environment, and to be able to deploy with some flexibility and reactivity and even scalability. as far as cloud native is concerned. And of course, microservices are playing a huge role in the Quarkus framework. There's different app density, different communication patterns, etc., that need to be supported in microservices, and Quarkus is designed to address that. And then lastly, serverless. I mean, let's face it, you know, a lot of the organizations I'm talking with, a lot of the companies I'm talking with are looking to exploit or take advantage of serverless technologies, specifically for the startup times. And traditionally, Java really doesn't fit or didn't fit in that space really well. So Quarkus was designed to address, you know, those, I guess, maybe challenges that a lot of organizations are having with running Java applications in a serverless environment. So Corkus, of course, was designed to address that too. And then, you know, I've mentioned microservices in the previous slide, and this is kind of a continuum from the monolith to the functions journey that a lot of organizations have embarked upon in their environments. Scalability is different, right? We're going from bigger processes to a framework that can accommodate more instances of services that might be running. You know, and there's a whole function versus, you know, the rest, and the ability to be able to scale down to 0, for example, scale up and then be able to scale down to 0, and just generally spend more time per microservice, starting up those services and running those services. So anyway, this is all kind of contributed and kind of formed the basis to what were the design choices behind Quarkus. So if you're curious about the name, by the way, Quarkus comes from essentially two. Oh, you're saying my voice, you can't hear me? Oh, okay. Someone else can hear me? Okay, sorry. I got a chat here that says you couldn't hear me. But okay, good. Thank you for those of you that responded to that. So if you're curious about the name, Quarkus, the smallest elementary particle, and of course us. And I think a lot of us will appreciate that, you know, we're the hardest thing to work with in computer science developers and those that work on services. So that's kind of the tongue-in-cheek description of Quarkus. So I talked about some of the, you know, what we're trying to address design-wise, and certainly some of the benefits of Quarkus are really, and these are the 4 primary benefits that we've really focused on. And we'll dive into each one of these individually. The first is developer joy. We want to make this an environment that's easy to work with, especially for developers, maybe those that are current Java developers, or those maybe in transition from Spring, for example. Going back to our serverless attribute or feature that we're striving to address, you know, we wanted a framework that was super fast and super lightweight, and that's kind of where the catchphrase comes from: the Supersonic, Subatomic Java. Another benefit, and again we'll get into these in a little bit more detail, is that, you know, we can unify, we can actually combine 2 different, you know, development paradigms, right? Usually, typically, you had to choose between imperative or reactive, and with Quarkus, you can actually use a combination of both of those paradigms. And of course, if you're developing Java applications today and you want to migrate over to a Quarkus framework, for example, we need to be able to and do support, you know, the best of breed frameworks and standards that you're probably using today and want to continue to use in the Java Quarkus environment. So let's dig into each one of these individually. And with Quarkus, you know, as I mentioned, we have to go kind of beyond simply working. You know, we're aiming for joy, developer joy, and it's just not being great for writing web applications or microservices. We're focused on, you know, more than just the feature set. We want to make certain that every feature works, of course, with little or no configuration, but we want it to be intuitive as possible. And it should be trivial to develop simple things and easy to develop the more complex ones or applications that you'd be working on. So we look for the most useful extensions. We made sure that they all work together and that every use case is covered and that out-of-box configuration is most sensible. So we want to make you more productive. That's really what it comes down to. And we want to make using Corkus enjoyable. So we introduced things like live coding. And this works out of the box. And I'm disappointed I'm not going to be able to show you this. But essentially, this works out of the box with no special setup. And it works with your Java files, your configuration files, any kind of static resources that you're working with. So essentially, when you create a Corkus project and you compile it, you do a Maven compile Corkus:dev is the command you use, and that launches Corkus in what we define as development mode. And essentially, what happens is when it receives any kind of HTTP request, it holds onto that request. It scans to see if any application source files have been changed. So let's say you're working in VS Code and you change a source file. It scans to see if any of those changes, those source files have been changed. And if they have, there's a compilation that takes place transparently behind the scene of those changed files, and it redeploys the application with the changed files. And then that HTTP request will continue and your application will be redeployed. So think of you're working inside VS Code, you change your application, you change a .java file. It's saved, maybe you have autosave, which is what we recommend. You just simply refresh the browser, and the changes that you made in your source files are immediately reflected on the change of your web page. So you didn't have to go through a typical recompile, wait, redeploy, retest, refresh, all those types of things. This happens and it redeploys right before your eyes, much faster than any kind of traditional application. So all but those huge, large applications would take under a second for it to redeploy. So it really raises productivity with application development. One of the other interesting aspects of Corkus, especially around developer joy, is this notion of unified configuration. So gone are the days of 1,000 configuration files and formats. We're aiming for some sort of cohesion within your development environment. So a single configuration file is all it takes for Corkus applications to configure every single extension. And not only that, but we've made sure that every configurable option has useful and sensible defaults. So you can get started with basically no configuration whatsoever. So where does this come into play? I'll show you some examples here in a moment as to the power of a unified configuration file. But imagine having all your configurations for your database access, username, passwords, all those types of things can be stored. Security parameters, debug options, all of those can be configured in one configuration file that's referenced, whether you're in a development environment, whether you're in a test environment, or whether you're in production. So that one configuration file can address all of those use cases. There's also, we streamlined. You see the note here about streamlining the code for 80% of the common use cases and flexible for 20. So what we've done is, as far as library support is concerned, is we've got a couple different ways to approach that. First is your Corkus applications can run on your existing JVM today, your OpenJDK, for example. You can run Corkus applications to run in that environment on top of HotSpot. And and work using the Quarkus framework. There are some exceptions to that rule, but in general, your applications will work fine in HotSpot. Quarkus applications will work fine. But there's also a native mode. So there's an extension in a technology called GraalVM is required, but you can also compile your applications to run natively. And again, going back to that fast startup time, that's kind of a requirement for serverless. This is really what plays really well into that aspect of things. So, so those are some of the things that we're addressing with Developer Joy. By the way, one thing to keep in mind is that there's thousands of ways to write the same code. We get all that. Every company has ways. Whether they're standards or traditions about how a project should be structured, and that's fine, but it kind of makes it hard to write simple documentation and onboard new developers and make things simple. So Corkus, we feel will focus on the simplest and most useful way to do that, to use any particular given feature. And so because of that, we kind of take an opinionated view about how you do that. And that'll be reflected here as we go along with the discussion. So I mentioned, the kind of the workflow that you're probably used to. You write code, you compile, you deploy, you refresh the browser, and repeat, right? Well, this live coding aspect of Corkus is really what's really powerful. You write the code, you refresh the browser, and you repeat, right? So you don't have to worry about waiting for all those long compile times, which can be rather long. Live coding is really what addresses that and really helps us. Because let's face it, it can be a major drain on productivity, and that compile, redeploy cycle can take minutes, which doesn't seem like a lot, but if you compare that to seconds with Quarkus, well, then you're in a total different realm as far as application development. So I mentioned the configuration file, unified configuration file, and this is what I was talking about. So Quarkus supports the notion of configuration profiles, and these profiles allow you to have multiple configuration values in this configuration file, which is called application.properties, and then you can select between them via a profile name. So the syntax is, % profile name and then .config.key and then some value. And there's some examples of that here on the slide. So you can see we've got a profile called prod, and we've got some configuration parameters set for our Postgres database in this case, and the driver. If we're in dev mode, then we're using, a different driver. And then we're in test mode, we're even using a different driver. So as you compile, so going back to, the Maven compile Quarkus :dev, if I'm in dev mode, then as you might imagine, Quarkus is going to reference those configuration parameters that I've designated for that profile. So in this case, it'll use the data source for the JDBC H2 mem : person, and the data source and the driver for the org.h2.driver. If I was in production mode, of course, it would use the top two. So this is what I'm getting at as far as being able to have a single configuration file, but be able to support the different profiles that you use along the development path. So whether you're in test or in dev, or in, I should say, dev or tested or in production, which is really powerful. And again, all of those configurations are in one file, so you don't have to worry about managing a whole bunch of different files. Okay, so we've touched on developer joy. Let's go down to the next benefit, which is speed and size. Going back to that tagline, Supersonic, Subatomic, Java. So here are some metrics that we share often around the size of an application that's running in a traditional stack, as you can see on the far right, So this is a traditional stack that probably many of you are using today. It's got kind of a green logo. In the middle is a Quarkus application that's running on the HotSpot VM, so a traditional OpenJDK VM environment. And you can see, we're roughly about half the size running in a HotSpot environment. And then if we compile down to native using the GraalVM, you can see we're about 1/10 of the size. So now that use case for serverless comes into play for Java applications, and specifically Quarkus. Because with that kind of footprint, you can not only using a lot less resources, our startup times can be incredibly faster. And here's the same metrics reflected with, a REST and CRUD application, and you can see, the same size benefits that we're seeing from just running in a typical hotspot environment or in a Graal environment, natively compiled. So startup times, obviously, size is one thing, but startup times are something that we're really focused on. And you can see those two applications that we just covered size-wise. The simple REST application, you can see the startup times of the traditional stack is about 4.5 seconds. And with Quarkus, natively compiled is about 0.016 seconds. And really impressive, obviously, with just the traditional hotspot VM. And the same is true for the CRUD applications. So really incredible fast startup times and real small footprints. And again, that's what we were striving for. I included this only because it's really interesting. And it kind of is, it's different than what I expected as far as response times over a given period of time with a traditional JVM and with a native compiled application. And it's a little hard for you to see, I imagine, but the blue line is actually the native compiled Java application. The red line, or maybe orangish line, is the OpenJDK version. Then we've got kind of a reference with Thorntail. But you can see over time, the actual response time for the natively compiled application stays pretty stable. And the OpenJDK one actually falls off a little bit, which is, I don't know, I think it's kind of counterintuitive, but nonetheless, it's kind of interesting that, even over time, where you expect the OpenJDK, especially hotspot, to optimize the application as it's running, we're seeing some fairly equivalent response times even over longer periods of time, which is kind of cool and interesting at the same time. Okay, benefit number 3, being able to combine imperative and reactive. Again, as I said it kind of at the onset, you typically had to make a choice between imperative or reactive approach to your application development. But with Corkus, you can combine the two. So you can actually use whatever technology fits, whatever the use case is for your application and what you're developing. There's some reactive extensions that we'll talk about here when we talk about the extensions, but essentially you can use those for event-driven applications, and again, it's really dependent on the use case and what you need for your applications. Benefit number 4, of course, is the best-of-breed standard frameworks. So this is just a small sample of some of the frameworks, and I'll show you more here in a moment. Some of these I'm sure you're probably using today or looking at, or maybe are exploring using. But all of these frameworks are supported out of the box with Quarkus, and you can choose to include whatever you need framework-wise in your applications and include those extensions in your applications. Okay, so let's talk a little bit about how Quarkus works. We've talked about some of the benefits, especially around developer joy, around the startup times and the size, being able to use reactive and imperative, and of course, the framework. So let's talk a little bit about how we get some of that performance that we showed you in some of those charts and graphs. So what we've done with Corkus, well, I should say the community has done with Corkus, is move a lot of what you would normally do or perform optimization-wise after the build into the build process itself. So typically what a framework does at startup time is, what you see here on the left-hand side of the screen, right? It parses the files, it does some class path and class scannings for annotations, etc. It builds the framework, it prepares reflection, all those types of things. And then it starts and opens the IO and the threads, etc. And then the optimization, what we've chosen to do is move everything possible, a lot of those things that you see on the left-hand side of the slide to the actual build phase. So what that helps us do is minimize a lot of the runtime dependencies. It lets us eliminate a lot of dead code that we don't need necessarily in our applications. It makes them a little bit more bloated, I guess is a term to use. And we can introduce some really clear contracts, some metadata contracts into the actual optimization of the framework. So all of this kind of contributes to some build time benefits, right? So you do it once at build time, not each time you start. So all the bootstrap of the classes are no longer loaded. So that means we can get those fast startup times. We can get those smaller footprints. And there's either no need or certainly less need for reflection or any kind of dynamic proxies. So obviously you can see or realize some really key benefits. This is what kind of that ahead of time compilation looks like. So all those things that we're doing at the build phase, this is what happens. We have, we compile, we have some sort of provisioning or curating where we include the frameworks that we want in the application, some of those extensions that I talked about a little bit earlier. There's some augmentation that goes on, right, the assembly. And then depending on if you're running it in a hotspot environment, so in your normal OpenJDK environment, or whether you're doing performing native compilation, you can see where we kind of fork off, and either we've got we create some sort of runnable and image for the OpenJDK, or we do some native compilation and then create a native executable and native image. And again, this is dependent on how you choose to compile your applications. What's needed for that native compilation is a technology called GRAL. You may have heard about the GraalVM. It's a polyglot JIT that supports Java bytecode and language, JVM languages. And it can interoperate with different languages, even dynamic languages through an API layer that I'll show you here in a moment with a block diagram, I should say. All that cross-language is out of the box, and there's support for native binary compilation via the substrate. And if we take a look, at least block diagram-wise, of what the GraalVM looks like, you can see a support for some of the native languages. You see Ruby and Python and R and JavaScript and C. You'll notice that I've highlighted some of the components of the GraalVM in red. And those are the specific components that we use or features that we use for Corkus. So we don't use the truffle, the APIs for the dynamic language. We don't use LLVM. We don't use a CI. We essentially just use these components, right? The substrate for the native compilation, the Graal compiler, and of course the VM. I see in the chat, can GraalVM replace or run Node.js? It can run Node.js. Yep. The GraalVM that you download from the community from Oracle supports that truffle API layer where which in turn supports Node.js. So yes, you can run. The reason I point out the layers that we're using for Quarkus is that we've established a downstream project from GraalVM called Project Mandrel. And the reason why is that, we were aiming to combine the best from both the GraalVM and the OpenJDK communities, if that makes sense. So we've backported required features to OpenJDK 11 to work with the native compilation and the substrate VM. It's not a fork. I want to make that very clear. It's not a fork of GraalVM. It's a downstream version that's aimed to make GraalVM easier to consume from an open source licensing and maintenance perspective. And again, by consuming those patches that I just talked about and the CVEs, for example, from the OpenJDK. So it aims to be a near drop-in replacement for the Graal VM. Right now, we're focusing mandrel on the native compilation, and it doesn't include things like the polyglot support that Truffle supports. Again, this is a project that we've just kicked off just in the last month or so to help us with the I guess an alternative packaging, we'll say, of GraalVM based on OpenJDK 11. It's still part of the GraalVM community. It's just a downstream version that frankly, we'll be able to support. So if you've got issues with you decide to go down this path and use Corkus and use native compilation, you'll have, you can reach out to us as an organization for support, which is important to a lot of organizations. So GraalVM plays a huge role, obviously, when it comes to native compilation. We've got a downstream project called a mandrel to address that. Okay, so I've talked about some of the really cool things about Quarkus. There's always a dark side to things. It's not perfect by any stretch of the imagination. So there's some things that aren't supported. And there's some reasons behind that, right? You saw some examples of the real small footprint and how we moved a lot of the optimizations to build time. And because of that, as you can expect, there's some things or features and functionalities that are typical to a Java development environment and application development that aren't supported with Quarkus. So some of those things are dynamic class reloading. So by default, the GraalVM removes all the classes and methods and fields that are not used directly in a call tree. So for this reason, it's necessary to manually register the classes that'll be manipulated using reflection, such as, domain classes, model, right? All those things that require some serialization using frameworks that use reflection. So, and usually that's done by annotating or using some configuration file when the class can't be modified. So some classes will not be required to be registered for reflection when Quarkus can automatically deduce them at build time. So again, moving those things to build time and analyzing the code. So right, Richard, right? No invoke dynamic, no lambdas. Yeah, at this point, right. So we had to forego some of those things to get the optimizations, the speed, the startup time, and size. Again, there are some things that I just talked about reflection that you can use with some caveats. Reflection manual list, it's just got to be it's got to be designated explicitly right at the onset, or else you can't use reflection. You can use things like dynamic proxies, again, manual. There's some JNI stuff that's manual. There's some static initializers. There are some things that you can use moving forward. But yeah, I see the ouch, Richard. I get it. But again, there are some trade-offs, right, that have to be implemented in order to get those startup speeds fast startup times and size. So we get it. It's not going to be perfect for every use case, and we understand that. But want to be upfront so that you know and understand. Of course, you can write. No, I won't go into that topic. We'll keep going. So anyway, the benefits of the GraalVM are that we support 100% of the Graal ecosystem. I'm sorry, the Corkus ecosystem is supported by Graal. All those frameworks that you're probably used to. We can use some reflection, obviously, if it's noted at the onset. We can minimize a lot of the dependencies. We can minimize a lot of that dead code that you normally don't use in your applications. So how do you build a native native executable? I mean, there are some prerequisites. Easy for me to say. By default, the native executable obviously is tailored towards your operating system. Because the container may not use the same executable format as the one that's produced by your operating system, you have to instruct Maven to build or to produce an executable from inside a container. Right? So you need some sort of working container runtime environment, which could be Docker, it could be Podman if you're familiar with that. You do have JDK. Obviously, you have to have the JDK installed. We're moving towards 8 is still supported, but 11 is the preferred. And moving forward, JDK for Graal, Quarkus moving forward. If you want to do native compilation, you just have to install a native image using a Graal command. So you'll install Graal and then install this native image, and that will help with the creating the executable, the native executable. And then you see just an example of how you would invoke that compilation of a native executable. You just pass it the minus capital P native. You can also dictate whether it's going to run in Docker, container, or Podman. And you can pass a command line parameter to that, or that can be in the configuration file that I noted a little bit earlier. So that's just an example of the compilation for a native executable. And again, kind of the flow, you take your application, you produce a native executable, you containerize it, and you end up with this container image that you can run in your environment. So again, those results, you can create a operating OS specific or native executable to run. There are some trade-offs, as we talked about, right? There's lack of that kind of build once, run anywhere, and hot reload capabilities with a native compilation. But the trade-off is obviously you have that smaller footprint and you have those quicker startup times. It's good for and really a perfect fit for those event-driven environments as serverless, as we mentioned a little bit earlier. And there's some statically compiled executable benefits. Those optimizations, some of those optimizations that we talked about a little bit earlier. So as far as use case, going back to maybe it's not going to fit all the use case. Lambdas could be obviously one of those use cases, but when you want to use which VM for Quarkus? If you've got high memory, dense applications, you're probably better off running on the hotspot, because those optimizations can still take place. If you're looking for the highest memory density for your applications, then the native image is the way to go. So anyway, you can see kind of the different use cases for each one of the hotspot or the Graal-based native image compilation. Okay, some more Quarkus. Getting started is really easy. I'll show you an example here of, well, at least from the website. Unfortunately, I can't show you the VS Code, which I'm really disappointed in. But you have to have a JDK of 8 or 11 installed. Maven, there is a Gradle option. So if you're using Gradle, you can use that instead. And then optionally, if you're going to do native compilation, you need to install the GraalVM, download and install the GraalVM. Speaking of VS Code, if you're using VS Code, there's a plugin, there's an extension, I should say, for Corkus that you can use in your VS Code. It's also recommended to use a Java extension if you're not already using that for your Java development, but there's a Corkus extension. To bootstrap your applications, and I'll show you this here in a moment, there's a site called code.quarkus.io, and it's designed to, as I mentioned, kind of quickly bootstrap your applications, and I'll walk through an example of that here in a moment. Going back to support, I mentioned support for mandrel, the downstream version of GraalVM. We also are offering support for Corkus. So if you're heading down the path and maybe thinking that Corkus might be great for maybe your legacy Spring applications, you want to migrate those, or maybe you've for any kind of new greenfield applications and you're looking for support, we have this notion of a runtime bundle, and Corkus is included in that, so you can get support. You can log support requests, and this is just what's included in those runtimes, support for all those things, including Spring. So you can see Corkus noted there, along with some other frameworks, including Vertex. I mentioned migrating applications from Spring. Going back to startup times, that's a real problem, a real world problem for a lot of organizations that use Spring. So we're talking with a lot of companies that are looking to migrate a lot of those Spring applications over to Corkus, and how do we do that? So we have an existing tool called the Migration Toolkit for Applications. It's a free tool that you can download, and essentially it's got a bunch of rules that you can customize that say, listen, today I've got a Spring Boot application, and you might include that jar file as the source, and then the target rule set would be Corkus, and you run this Migration Toolkit for Applications, and it does an analysis of your Spring jar application, and it produces a really nice output, a report in agile terms, and it kind of it identifies those things that you're going to need to change in order to migrate your applications to Corkus. So it comes with a really nice report that kind of helps you. It doesn't do the migration for you. It's a tool to help you identify what things that you need to change to be able to migrate your application over to a Corkus environment. Maybe it's libraries or extensions, whatever the case may be, it'll identify those. So with the tool as it exists today, we've got kind of a minimum viable product seeding for Spring Boot to Corkus applications. So we've got a minimal set of rules today to help with the migration, but we'll have a much larger, broader rule set in November when we release the next version of the Migration Toolkit for Applications. Again, this is a free tool that you can download and analyze. By the way, if you're looking to move from the Oracle JDK to OpenJDK, this is a tool that will help with that analysis too. Or you're looking to move from WebLogic to JBoss, for example, you can use this tool to do that type of analysis too. So it's really flexible. A tool, and we've included now some rules for moving from Spring to Corkus. Okay, and then lastly, a bunch of resources. You can get access to these slides. I'd be happy to send them out to you. I'm not certain if there's going to be a repository for all the slides, but I'll send those on to Chad if there's going to be a repository. Anyway, some links here that are really useful. The Corkus cheat sheet is really a great document. It's actually referenced on the Corkus site now, so you can get access to it from there. Link to the GraalVM. There's also a link to the roadmap if you're interested in what's coming down the pike, or if you have an interest in some features, functionalities. I see Richard, offered a suggestion around a compiler flag around lambdas and method referencing without using invoke dynamic. That's a great suggestion. So, that's the great thing about how about community developed technologies like this, that you can have impact, or submit an RFE, or contribute to the project in general, right? So that'd be a great opportunity for you, Richard. Hey, that's a good opportunity for you, Richard, to get involved in the community. And if you need help with that, getting involved, please don't hesitate. I can help you with that, of course. So hopefully we covered all those benefits. Again, I'm really disappointed, and I'm sorry that I couldn't show you some of the examples, both from a VS Code and the builds. I had some really compelling. I actually went through some builds of the containers for you, right? I can show you. Boy, hold on. Let me just get to the end of this. Okay, so we're at thank you. Okay, let me go back here. I'm going to stop sharing this just for a moment. And let's see here. I can get here. Okay, so let me go to code. Quarkus.io. Okay, let me make certain. Okay, I just want to make certain I'm sharing the right screen here. You should be able to see the code.quarkus.io screen. So this is where you can quickly bootstrap an application. So there's a couple different ways that you can create a project using Quarkus. Number one, you can use code.quarkus.io. So you can create your group name, right? You could do combat Red Hat, whatever the case may be. You can change the application. Code PaLOUsa. You can. I mentioned that Gradle is available. It's in preview mode right now, but you can choose between your build tools, snapshot, final version, and then I mentioned earlier about all those extensions that are included. And I'm just going to scroll down the screen here, but I encourage you to go look at the extensions. I mean, there's a lot of extensions that cover a lot of different frameworks and technologies that you're probably using today, from messaging to reactive to cloud to security, a bunch of Camel integration extensions, tons and tons and tons of them. Some around business automation, you get it. There's a compatibility layer for those Spring applications that I mentioned a little bit earlier, Kotlin, and Scala in preview. So you get it. There's a lot of different extensions, and we're adding more as we go along. But what you can do here is just simply choose those extensions that you want to include in your project, and you can see the applications I've selected, and you just click on. You can generate the application. You can download as a zip. You can push it to Git, or you can share it. So I can just say download as a zip. So it created the zip file with all those with everything, all those extensions. I can unzip that, and I can run, a Maven compile Quarkus dev, and I can start, testing and running that application. So that's one way of quickly bootstrapping. You can also do it via the command line too. In fact, here, let me do this. Since I wasn't able to show you. Oops, let me go back to this application window again. So this is what I was going to show you. And what I'll do is I'll send this along since I wasn't able to show it to you. But anyway, and let me make this a little bigger so you can see it a little bit. But I was going to run through building a native container. Native build. I was using Builda. You can use Docker. I was just using Builda as the build tool. instead of Docker. You can just plug it right in. I was going to build the JVM version of the container, run that with Podman, show you the memory consumption. In this case, with the JVM version of the container, it was about 150 meg, if I recall offhand. And then I was going to show you the native compilation version of that container, which was about 30 meg in size. So I'll send this out. You can walk through the examples. Anyway, it's really cool demonstration to show you, because it shows you, number one, how quickly these applications start up, in microseconds. But number two, it shows you some of the cool aspects of it. I was going to show you how you can change your properties file and include that. So there were some cool things that I was going to show you, but unfortunately we couldn't do that because of some technical difficulties. But anyway, we're wanted to leave some time for any questions that you might have. Thanks, Richard, for those questions that you had and comments in the chat. If by any chance you want to hear or learn more about this, let me throw my email back up on the screen so that you can have access to that. Please feel free to send me an email. I'd be happy to run through this demonstration. Oops, let me go back. Run through this with your organization. I also have a Java performance and tuning session that I've been working with a lot of organizations on that seems to have gotten good response. It's pretty in-depth. It's probably about 2.5 hours, but we go through all aspects of tuning your Java applications. Not necessarily from a code perspective, but from what parameters to use, what garbage collection might be best for your applications. We focus a lot on startup times, optimizing containers, which obviously plays into the Corkus discussion too. So by all means, if you'd like to have either of those discussions, feel free to send me an email. I'll be happy to jump on with your organization as it is virtually today and talk about those topics. But I appreciate you hanging out with me today. I appreciate, I'm sorry that I wasn't able to show you some of the things I wanted to show you by VS Code and some of the other demos, but again, we can do that on a different day. But thanks for joining. Any other questions before we sign off here? Great. If not, enjoy the rest of the conference, and we'll talk soon. Have a good weekend, everyone. Take care.